Okay, this is exam 3 for physics 201. It takes 100 meters to stop a car initially moving at 25 meters per second. The distance required to stop the same car at 50 meters per second under the same conditions is what? Okay, well, I have twice the speed, and since the kinetic energy is 1/2 mv squared, if I double the speed, that means I quadruple the kinetic energy. Now, I know that work is equal to a change in kinetic energy, and so a force is stopping the car over a distance of 100 meters. So I can say F times D equals, excuse me, change in kinetic energy. This is going up by a factor of 4. The force is remaining constant. So the distance is also going up by a factor of 4. So it was 100 meters. Now it's going to be 400 meters. Consider this figure. A cart starts at point A with a speed of 4 meters per second. Which of the following statements describes the cart energy at point D? Okay, well, at point D, at a lower height, so rather, doesn't matter there. I'm at a lower height. That means that I have, excuse me, I'm sorry, it doesn't really matter at your lower height. I am at a certain height, so I have potential energy, and it's also moving, so I also have kinetic energy. It could have been at the same height as point A, because I have kinetic energy up here at point A, but the point is that I have both potential and kinetic, so D is the right answer. By what factor does the kinetic energy of a car change if its velocity is doubled? All right, well, kinetic energy is 1/2 mv squared. If I double that, I quadruple the kinetic energy because it's 2 squared. Entergy reads kilowatt hours from our electric meters. What is this a measure of? All right, kilowatt hours, that's joules per unit time. I'll just say seconds times hours, which is another unit time. So this is equivalent to joules per second times seconds. Those cancel, give me just joules, so energy is the right. It's a measure of energy, not power. Which of these statements is true? Conservative forces require contact between two objects. That's not true. Field forces conserve energy. That's true. Actually, they're not contact forces. They conserve energy. Friction is a conservative force. Definitely not true. Conservative forces are path dependent. No, that's not true either. Non-conservative forces are path dependent. So two only. C. Two paths lead to the top of a big hill. One is steep and direct, while the other is twice as long but less steep. How much more potential energy would you gain if you took the longer path? Since potential energy is the result of a conservative force, the gravitational force, you gain the same amount of potential energy. A. Spring has a spring constant of 1200 Newton meters. You apply a force of 600 newtons. By how much do you compress the spring? Well, I know F is equal to Kx. 600 equals 1200x. So x is 0.5 meters. D. An open cart rolls along a frictionless track while it is raining. As it rolls, what happens to the speed of the cart as rain collects in it? Well, my momentum is remaining constant because there are no external forces acting upon it. My mass is going up. That means my speed is slowing down. C. I have this perfectly inelastic collision. That means they stick together. What is the magnitude of the final velocity? Okay, well, my initial momentum is 2 times 4 plus 4 times negative 3, and that's going to equal my final momentum, which is going to be 2 plus 4 times v. That's 8 minus 12. It's negative, or yeah, 8 minus 12 is negative 4 divided by 2 plus 4, which is 6. That's equal to v, so that's 2/3, 0.67. Uranium nucleus is at rest and undergoes fission and splits into two fragments. Which of these statements is true? We're assuming here that initially my momentum is 0 because it's at rest. It undergoes fission. If its initial momentum is 0, its final momentum is also 0 by the conservation of momentum. We could also say, since the final momentum is 0, the momentum of particle 1 is equal to the opposite, the momentum of particle 2. Because this is lighter, it's going to have the bigger speed. Because this one's smaller, it'll have the smaller speed. So let's see, the heavier fragment has a higher velocity. No, it actually has a lower velocity. They have the same momentum, but in opposite directions. That is the correct answer. They have the same velocity. They do not. The bit smaller one has the bigger velocity, and the lighter fragment has more momentum. It has the same momentum as the heavier one. Force of 100 newtons acts on a 100 kilogram boulder for 2 seconds. Same acts on a 1 kilogram stone for 2 seconds. Which experiences the larger change in momentum? Well, by Newton's second law, I know that F is equal to dp dt. the change in momentum over the change in time. Here my force is constant. The time is the same, and so if this is constant and this is constant, that means dp, the change in momentum, is also going to be the same. So C is the right answer. Which of these bodies has the largest momentum? Well, momentum is m times v. So here I have 8m times v, so that's going to be 8 mv. In fact, I'm just going to put the coefficient there. 8, 3 times 3 is 9, 2 times 3 is 6. So the third particle alone has the highest momentum with a momentum of 9 times m times v. The momentum of an object is tripled. Its kinetic energy be changed by what factor? Well, if a momentum is tripled, that means the speed is tripled, and so its kinetic energy, 1/2 mv squared, will increase by a factor of 9. Which of these has the largest energy? Well, again, 1/2 mv squared. So this one is going to have a quantity of 1/2 8 mv squared. This one will be 1/2 64 mv squared because I square that 8. The third one is 1/2 3 times 9, 27 mv squared. And then this was 2 times 9, or 1/2 of 18 mv squared. So let's see, let's cite 2 alone. E is the right answer. Rubber ball and Olympic putty having the same mass are thrown with the same speed toward a wall. The ball bounces back with nearly the same speed as it hit. The putty sticks to the wall. Which of the two experiences the greater change in momentum? The ball experiences the greater change in momentum. Remember, delta P is mv final minus mv initial. Here, for the putty, v is 0, so I'm just left with mvf. But for the ball, it's going to be mvf minus mvi. But remember, vi is a negative number, so these two negatives are going to cancel out, and it's actually going to have about double the momentum. If it has the same speed as it hits it, it's going to have double the momentum of it originally, of the putty. All right, a cart with a mass of 35 kilograms begins at point A with 0 speed. The track is frictionless. What is the speed of the cart at point B? The speed at the top, it only has potential energy, because at the top V is 0, so kinetic energy is 0. Here it only has kinetic energy, because H equals 0, so the potential energy is 0. So I say the potential energy at the top equals the kinetic energy at point B. So this is point A, this is point B. M times G times 8 meters equals the kinetic energy at the bottom, 1/2 mv b squared. Notice my masses cancel. I'm left with 80 divided by 0.5. The square root of that, that's the square root of 160, just 12 point something. 12.6. We'll just call it 13 to keep two sig figs. So 13 meters per second is the right answer. If the speed of the cart is 10 meters per second, what is the height h? All right, so this means the speed of the cart at point C. So up here, I have a v equal 10 meters per second. Okay, yeah, so I have a speed here of 10 meters per second, and I want to know what is the height h. Well, I have, I can compare the energy here to the energy here, and over at point A, I only have the potential energy at point A, but at point C, I have both kinetic energy and potential energy. So this is going to be m times g times 8 meters equals 1/2 m times 10 meters per second squared plus m times g times h, which is what I want to know. Notice my masses all cancel, divide through, and I get 8g, or 8 times 10, divided by, pardon me, not divided by, minus 1/2 of 10 squared, that's 50, divided by g, which is 10. 80 minus 50 is 30, divided by 10, 3 meters. So for part B, the answer is 3 meters. On a flat part of the track, the cart encounters a resistive force given by the function above. How far does the cart travel before stopping? Okay, so I have this force that's acting to slow it down. I know that at this point it has a certain amount of energy. I can just say that it's the energy over here at 8 meters. So at this point it has an energy equal to the initial total potential energy, which is 35 kilograms times 10 meters per second squared times h, which is 8 meters. 50 times 8. It's 2,800 joules. I know that this force is going to take away all of this energy. And so I need to figure out what distance over that force acting does it take away all that energy. Let's go down here. So I know that the total energy of the object is 2,800 joules. And I know that the force is negative 4x cubed. I know that that force will do a certain amount of work, which would go to change the energy of that object. The work of that is going to be the integral of f dx, and it's actually and it's going to change the energy. It's going to cause it to decrease by 2,800 joules. So I want to solve this for xf. Okay, so the integral of the force, which is negative 4x cubed dx from 0 to xf is equal to negative 2,800. I'll just go ahead and get rid of these negatives. This is going to be 4x to the 3 plus 1 divided by 3 plus 1. It's 4x to the 4th divided by 4. These cancel. X to the 4th equals 2,800. I take the 4th root of both sides. So 2,800 to the 0.25 power. I get 7.3. So it travels a distance of 7.3 meters. All right. Let me actually point out something here that we've done, but I haven't really talked about. When we have this, I know that work is equal to force dot displacement, the dot product of those two. What I'm doing here actually, and I don't have to point out because, or I don't have to do it here because F and X are in the same direction, but really what I'm doing is I'm taking a dot product of the force and the differential element dx. But since the force here is only in the x direction, I don't have to really worry about that, but that's really what I'm doing. All right, a 3 kilogram object sits on a frictionless flat surface. The force acts on the object. The force is given by the following function, and the force acts over this distance. What work does the force do on the object? Well, my work is F dot D. That's 4I plus 6K. Dotted with 5I minus 2K. So I have 4 times 5, that's equal to 20. Remember, I'm just multiplying the like terms. 20 minus 12, which is 8.0 joules. So that's the amount of work that's done on the object. What is the final velocity of the object? Well, my final velocity, my work causes to change my kinetic energy. So I'm doing 8 joules of work to 1/2 mv squared I have a 3 kilogram object. Uh, so that's going to be 8 divided by 1/2 of 3. The square root of that at 2.3 meters per second. And let's see, I asked for the velocity, but really I just want the speed, so I'll change that on your test. And then the object travels until it encounters a spring with a spring constant of 1200 Newton meters. Spring compresses the object compresses the spring and comes to rest. What distance does the spring compress? So I have this amount of energy, 8 joules. All that energy is now going into the spring, into elastic potential energy. So let's see, 8 joules divided by half of 1200 newtons per meter. That's equal to x. 16.12 meters, 12 centimeters. All right. Have this inelastic collision. What is the final velocity and vector notation of m2? So initially, I only have momentum here, and then in the final state, I'll have momentum in both of them. So I'll set up my initial momentum, set it equal to my final momentum. My initial momentum equals my final momentum. I'm going to have P1I plus P2I equals P1F plus P2F. P1I is 0 because it's not moving. P2I is 2 kilograms times negative 3I plus 1J. That's equal to P1F, which is, what was P1? 1 kilogram times negative 3I minus 2J plus 2 kilograms times VF, V2F. And I solve. So I have negative 6I plus 2J equals negative 3I minus 2J plus 2V2F. And I solve. I keep my I and J components together, as they should be. So I get negative 6 plus 3, negative 3I plus 4J equals to 2V2F. Divide through by 2, I get negative 1.5I plus 2J equals V2F. Or if you want to be actually particular about your SI units, it would actually be negative 2I, keeping one sig fig. But I would take either of these. That's just because I only gave you one sig fig here. So you should have one sig fig in the answer, but I would take either. All right, we'll call that the right answer. All right, what's the difference between an inelastic and an elastic collision? Well, the difference is an inelastic, or rather an elastic collision, conserves energy. An inelastic does not. An example of an inelastic collision, well, any collision, really, that's not an elastic. Let's do an elastic collision. This would be like the collision between gas particles, for example. anytime you have a field force that's at work, it's an elastic collision. Are charged particles, if you will, charged gas particles. An example of an inelastic collision, every other thing, so a car crash, for example. All right, accepted a variety of answers for that. Firefighter sprays water horizontally at 10 meters per second directly at the wall of a house on fire. If 25 kilograms of water are delivered in 2.5 seconds, what is the magnitude of the average force on the wall due to water, assuming that the impact, the water falls straight down down the wall? Let me pause for just a sec. Okay, so here I'm looking at F is equal to dp dt. dp is m dv dt. Remember, this is just Newton's second law. Here, our mass isn't changing. I have 25 kilograms of water, but the water is traveling at 10 meters per second initially, and then it's traveling at 0 meters per second. So my change in velocity is 0 meters per second minus 10 meters per second. Or this is Vf minus Vi, divided by the change in time, which is 2.5 seconds. So that's 25 times negative 10 divided by 2.5. 250 over 2.5 is 100 newtons. I think I was just asking for the magnitude. Yeah, what is the magnitude? So the answer then would just be 100 newtons, so I would take negative 100. And I believe that's it. There's the multiple choice answers.